Hey, today we're going to cover CASL and how to integrate it with NestJS. So I have a couple recommendations for you if you haven't seen them before. First of all, I would recommend that you watch the last video I made actually was on CASL and the fundamentals of how to use it, what it is, and stuff like that. And then I also had this video on NestJS authorization, which covers the basics of how guards work. And then finally, you can't really do authorization in an application if you don't already know who the user is. So ideally you have authentication in place. So if you don't know how to do authentication for your application, I also have a video on that. I talk about how to do, username logins and JWT sessions, stuff like that, all that good stuff. It's in that video. All right, so let's jump right into it. So I have a folder here in my desktop. It's called NestCastle. And what I'm going to do is I'm just going to initiate a new Nest project in here. Ideally, you also already have the NestJS CLI installed globally. Here's the command if you need to copy it. I've already got that installed, so I'm just going to do nest new and I will scaffold a new application for me. I'm going to select npm and that's going to install my dependencies. All right, so that's already installed and you can see it generated a bunch of files for me on the left here. Now, right off the bat, I'm actually going to add another dependency, which is CASL itself. So make sure you install @casl/ability. Now, before we get started, it's probably a good idea to design some sort of API that we're trying to protect with authorization. So imagine that we have user CRUD, right? So we might have get user by ID. You can post a user to create a user. You can patch or maybe a put would work there as well. And you can also delete, right? But in a typical application, you don't necessarily want to provide all of these capabilities to every single user. So let's imagine that we have the concept of an admin. So let's say that if you are an admin, so let's have a variable called isAdmin. You can basically do everything, right? You can create, read, update, delete, so all of these. And if you're not an admin, we're just going to say that the only access that you have is to read, right? You can read the data. You can see other users. You can see your own information, but you can't update or delete any user. And we're going to evolve these requirements as we go. So we're going to revisit this later, but this is sort of our initial requirements. So to get started, if you didn't know, Nest actually has a really nice CLI that allows you to generate a new resource, and it'll give you all of those CRUD endpoints. So we're going to do nest G, which is generate for short, resource, and we're gonna do user. And I'm gonna select REST API here. Although, by the way, the stuff we're covering here, it doesn't have to be REST. It could be. It also applies to GraphQL, since the concept of guards, it doesn't care what your transport layer is. It still works regardless of whether you're using REST or GraphQL. But for this demo, we're just gonna stick with the simple REST API. And we're going to hit yes here to generate CRUD entry points. So you can see that it created all of these files. There's now a user controller. You can see that this actually generated all of those routes that we wanted in our requirements, right? So we have our get user, we got one for get user ID, and then we have a patch, a delete, and a post for create, right? So this is basically all of the requirements that we have so far. So our goal is to restrict this API to provide this specific access. Again, this is our requirements. We're going to keep revisiting this. Now, one of the things that got generated also is this user entity, which is going to define effectively what our user object looks like. And this could also represent a database table if you wish. Like if you were using type ORM, you can do that. So we said that a user, well, first of all, they have probably some kind of ID. And we also said that there's some kind of Boolean property that determines are they an admin or not. So we're going to add isAdmin, right? So we're going to start with that. It's going to be very simple. So next, what we're going to do is we're going to create a module for the authorization stuff. So all the CASL stuff, right? NestJS is very big on encapsulation. So we're going to create a module. We're going to do nestg module, and let's call this ability. And while we're here, we're also going to create a class ability, since this is actually the folder of the module we just created. So src/ability, we're going to do ability/ability.factory. right? And you can see that that created us a file called ability.factory. We're going to open that up. And this is going to be the main file where we define the user rules and permissions. So the first thing I'm going to do here is I'm going to add injectable here to make sure that this is, it's a provider. And then I'm going to add a method called define ability for, and that's going to take in a user, right? So that's going to have the type of our user entity. And this is where we're going to define the rules, the different abilities that the user has. Now with CASL, like I talked about in my last video, you can define a set of actions and a set of subjects. And basically your rules, your permissions is just a combination of all the actions that you can do on a certain set of subjects. So first, let's start by defining a set of actions for our application. Generally, most people can start with just CRUD, create, read, update, delete, and then manage. Since manage is sort of a special action in CASL, it's sort of like a wildcard for any action. All right, next we want to define the type for subjects. And what are subjects? It's really anything that you may or may not want to restrict access to. And typically that's just your entities, right? Because you typically would want to protect who can update or create any of those entities, who can delete them, just like what we're trying to do with users. So user is one of our subjects in this simple example. Now subjects in CASL could be as simple as a string, but they can also be classes, they can be objects. And since CASL is written in TypeScript, we actually want to make sure that we're using the correct interfaces when we create these types. So for example, if we want to say that user is one of the subjects, we can use this in first subjects from CASL. You can see this is importing from CASL ability, and we're providing the type of user, right? So that's generally how you provide your subjects. And if you have more than one subjects, like in our case right now, we're starting with just one, you can add it to here. So for example, you can do type of, maybe you have a post subject entity, right? So we're going to go back to just user. And then you'll notice that we're also doing all, because all is a wildcard for any subject, right? Just like how we have a wildcard for actions, which is the string manage, all is the wildcard for any subject. And then effectively, we want to join these action and subjects together to define the overall type for our CASL ability. So we're going to add type app ability, and we're going to import this ability from CASL ability. And you can see that it's saying we're creating an ability that specifically has these actions and these subjects. So with that in place, we can now bring in our ability builder. So if we did builder equals new ability builder from CASL, and to use ability builder, you actually need to provide this ability object in here, right? So that's generally how you create a ability builder with CASL, is you use the ability builder, pass in this ability object in here, and then you can start using that builder, right? And this builder provides methods like .can, and that's the main thing that allows us to start defining what can a user do or can't do, right? And you can see that can takes in an action or a subject. Now, there's one catch here because we're missing something. You'll notice that we haven't taken advantage of what this app ability is yet. So you'll notice that if I provide a random string in here like test, this assumes that we have an action called test because it doesn't know about this enum that we created, right? So to improve the types here, we need to make sure to cast this ability object to our app ability. And the way we do that is we're going to do as ability class, which you also import from CASL ability, and then provide in there the custom type that we just created. And now you can see that we have red squigglies here because it's expecting this enum. It's expecting a, for example, action.read, right? And it's also going to do the check for us to make sure that this is a correct subject. So for example, if I just provide a random object in here, it's going to break, but user should be allowed, right? So at this point, we can actually start defining the permissions for the different users that we might have. Now to make things a little bit simpler, I'm actually going to deconstruct can and cannot and build so that we can just do, can. Right, so let's go ahead and open up our requirements again. And our goal is to now start implementing our requirements on the right here. So we said that, our user can be an admin. So if we did if user is admin, we can give them certain permissions. So we can do can action.create user, and you can repeat this for all of the actions like create, read, update, delete. Or we said that manage is a wildcard for all possible actions. Since our requirements say that basically an admin can do anything, we're just going to change this to manage, right? So this says that an admin can basically do anything with a user entity. And you can even change this to all if you wanted to, which would allow an admin to basically be able to manage anything across your entire app. It's really up to you how much you want to restrict this. We'll just start with that. And we're going to say that if you're not an admin, the only thing that you can really do is action.read. And again, you can also specifically provide the user type here, the user subject. But typically for a non-admin user, they would have read access to most things in your application anyways, right? And again, this is assuming that you have authentication in place. So assume that the user is already logged in. Let's just say that they have read access to everything, right? So those are very simple requirements that pretty much allows us to do what we have defined here so far. And you'll notice that we haven't used cannot yet. We'll see an example of that in a little bit. We're going to evolve this as we go. But for now, what we're going to do is we're just going to return build. And this is going to build our set of abilities for a given user, right? That's why we have define ability user. Now there's one piece of configuration that we need to add in here, which is detect subject type. And we're going to make sure to import extract subject type from CASL ability. So this is just saying that if it sees an object, it's going to look at that object's constructor and it's going to figure out if, what subject it is that we're trying to talk about, right? So for example, if we did change this back to can user read, right? It's going to check that it's actually of type user. So I hope that makes sense. But if it doesn't, there is a documentation on subject type detection in CASL if you want to learn the deeper details about it. All right, so now that we've defined our base permissions, and we're going to update this more as we build this out, make sure that, because this is a provider, we're going to make sure that this is actually we have to make sure that this is actually in our ability module providers, right? So we have to add that in here. And you also want to make sure that it's in your exports array. That way other modules can import your factory. So as an example, if we had the users module, we can add in here a imports ability module. And since we had the ability factory as an export of ability module, that means that everything else inside this user's module can now inject that ability factory. Let's go to our user controller, and that means we can now do something like this. Private ability factory, which is a type of our ability factory, right? And at this point, let's actually just run our application so that we know what the current behavior is before we started protecting some of these routes, right? So in my terminal, I'm going to do npm run start dev, and that's going to start my application in localhost 3000. And then I'm going to use Thunder client here, which is, it's kind of like Postman if you haven't seen it before. So if I do a get on 3000/user, we get back on the bottom here, this action returns all user. And actually I made a mistake earlier. I should have named this users, not singular user. So I'll just rename the path here to be users. So that makes a little bit more sense to me, right? We're getting /users, a set of users. All right, so we have that in place. So, and you can see that we have the different methods, right? So for example, we can also do post on /users, and that's going to return as a 201 created and a response that says this action creates a user. We can also do delete on user/id, right? And we see the response says this action removes a user. Same thing for if you do a patch, right? Now we need to start protecting these routes so that only admins have access to manage users. So how do we do that, right? So remember that we now have this ability factory injected into our user's controller. So let's start with the create here. We're saying that only admins can create a user. So we're gonna do ability equals this dot ability factory that define ability, and then we said that we need to provide a user object here. And what is that object? That's gonna be the current user. Now, typically, again, I mentioned that you ideally already have authentication in your application, and the general convention when you do authentication, with Nest or Express, right, is that usually you'd have the user in, request.user, right? But we don't have that right now because we didn't implement authentication in this application. So we're just gonna imagine that this exists, okay? So imagine that we do have request.user, and that brings back an object with an ID of 1, and we're gonna say is admin is false. Right, so imagine again that we have auth, the user logged in, this is their details, and typically that's being pulled from request.user, but because we don't have it, we're gonna mock it. So we're gonna take this user, the current user, and we're gonna provide it to our factory, and that's gonna create us an ability. And remember that ability effectively defines, what can and can you not do. All right, so with CASL, there's pretty much one way to check if a user has a certain permission, and it's sort of like this. So let's say that we have a variable is allowed, and to determine if the user is allowed, we're going to do ability.can, right? So this is very similar to the same method that we used to define. It's also can is also what we use to do the actual check. So we're going to say action dot, and we're gonna need to import that enum that we have from the factory. So we're gonna do action.create a user, and we'll also import user from our entity class file, right? And very simply, if is not allowed, we're gonna throw a new forbidden exception. And if you didn't know, this is one of the built-in exceptions in NestJS. If you throw this specific class, it's automatically going to respond with a 403, I believe. So for example, let's provide a message in here like only admin, right? And now let's see how our application behaves if we try to do a post on /users. And again, remember that our fake current user is not an admin. So if I hit send here, it's going to send me a status of 403 forbidden response with my message in there, right? So that's really the basic gist of it, is that you need the current user, ideally from your authentication solution, and then you create the ability using that user and your factory here, and then you do a check. Now there are also other ways to do this and more advanced ways to do this with guards, which we'll cover in a sec. But before we get to guards, I also want to show how to use the ForbiddenError class from CASL. So another thing that you can do, for example, is let's do a try catch block here. What you can do with CASL is use this ForbiddenError class. You can see it's from CASL ability. So we're going to import that. And this exposes a method called from, which you provide the ability to, which we got from our factory. And then it has another method that you can chain in here called throw unless can, which is effectively the same exact can call that we have here, except that it's automatically going to throw a specific exception if it can't, right? So we'll also take our action and subject user in here, provide it there, and then we're going to move this return the actual service call to create the user within here. And then if you want to, you can specifically catch this specific error and then, turn it into a different type of exception, kind of like the forbidden exception that we have here. So we can do, if error is instance of that forbidden error, we're going to do forbidden exception error that message, right? But where do we define the message? There's a couple places that you can do this in. So one is you can actually add a set message method here and make sure this is before the throw unless can, and you can add your message in here, right? And let's see how that behaves. It should behave differently, but we'll get a different message. So if I do a post 3000/user send, same thing, 403 forbidden, but we have a different message, right? So this is effectively the same thing as this one, which I can imagine someone is probably thinking, but isn't the one at the top simpler? To a degree it is, but you probably don't want to keep doing this if statement and throw everywhere, because this is throwing a specific error. There is a very specific benefit to that error that's being thrown, because in NestJS there's this concept of exception filters, and you can define basically a global catcher of sort, right? So like the exception filters is actually, there's one that's built in that's catching these forbidden exceptions. However, if you wanted to catch a specific exception or a specific error, you can define a custom exception filter. So for example, kind of like how they're doing here, you notice that they have an exception filter that catches everything, but then they check what instance of that error, that exception, is being thrown. And in here, you can instead check, is it an instance of forbidden error? And then you pretty much can remove this try catch block and just globally do that catch everywhere, right? So this actually ends up being cleaner for you if you start using exception filters. So this code effectively just becomes like this. And then if this does throw, it's automatically going to be caught by that custom exception filter. And that becomes very clean in my opinion. So that's the reason why I specifically introduced that here. But since we didn't implement the exception filter, we'll bring back the try catch here. And there's also another benefit of using forbidden error is that you can actually set the message on the definitions themselves in your ability factory. So for example, if you can also define the inverse using cannot, right? So if I explicitly provide a cannot rule, like action.create user, the inverse rule actually has this extra method called because, and I covered this in my CASL video, but just as a summary, this basically allows you to define your special message in here, which basically allows you to centralize all of your forbidden messages in the same factory that you have here, right? So it sort of centralizes everything in one place. And now I can remove the set message in here, and let's do another simulate post on/users. And now we got our new message here that's coming from our factory, right? So as you sort of implement these pieces, it starts to get more and more cleaner, right? So that's the primary benefit of using the forbidden error throw unless can, is it can utilize those messages if you want to provide that context to your API consumers. Now, if you don't care about that and you're okay with like a generic 403 forbidden, you can't access this, and you don't really want to provide messages, then you can just stick with the simple cans and don't provide the inverse or messages. And that's also another way to do it. It'll be a little bit simpler. All right, so let's take this a little bit further in our requirements. Let's add another requirement that says, let's say that our user object now has the concept of organizations, right? Imagine that you have groups of different types of users, and you have the admins can only manage the user in their own organization, right? So let's add to our requirements here of, if admin, they can do all of these if in same organization. So what we're gonna do is, in our ability factory, we're gonna go back in here and we're gonna add an explicit rule that says you cannot action.manage a user if their org ID, and we're gonna add this in our entity in a second here. We're gonna say if their org ID is not equal your own org ID, because you can only manage users in your own organization, right? And this is actually if you haven't seen this before with CASL, I recommend reading the documentation for conditions in depth, But basically what they did is they tried to simulate a similar query language to MongoDB, right? So they have these different operators like equal, not equal, less than or equal to, greater than, etc., right? So there's a bunch of things that you can do to add conditions to check if a certain object has the right properties that you expect it to have, right? So that's why we're here. We're saying the org ID of the user that you're trying to manage needs to have the same org ID as you. Now there's red squiggly here because we don't have org ID in our user entity. So we're going to add org ID number, and back in our factory, that should be looking pretty good. And we'll also need to clean up our mock users here. So we're going to add org ID 1 here, just so we don't have the errors. But anyways, now that we have that new rule in for updating, we can do the same exact thing that we're doing here in update. But there's a tricky part to this, which is that you don't already know what org the user being managed is until you pull it out of your database, right? And typically you would define that logic within this service method that we have. This is probably going to query the user from the database and then update it, right? So if I copy that code down to here in our update, we can do the same. And let me also copy this try catch down here, but we're going to replace the return to be, our update. But there's something missing here, right? If we just update this to be action.update user, how does it know what ID is the user that we're updating, right? And it doesn't. It needs to be pulled out of the database first if you did have a database. So you have a couple options there. One is that you can first do something like, user to update equals this.user service find one. This is one of the sort of mock functions that they auto-generated for us. You'll see, this returns an action with an ID, right? So if we were to provide the ID in here, and that needs to be a number, and then we can take that user to update and provide it here as a subject instead of just a type, right? But we have a squiggly here because this is returning a string and not an actual user object like it should. So if you go in our find one, we can kind of mock the behavior here by creating a new user, but imagine that we're actually pulling this from the database. So let's say that this user has an ID of 2, and let's also say that their org is also 2. And actually, we'll just do the ID to be the same here because we're trying to mock that being pulled from the database, right? So we're just going to return that user. And now I think that the types should work out so that this is actually a user object. And now we can use it here. And this should work, right? So let's try to test here. If you were an admin, but you're in org ID 1, remember our user to update is in org ID 2, right? So this admin should not be able to update this user. So if we do a test on patch/user/2, we're going to get a forbidden saying you can only manage users in your own organization. And if we were to change our org ID to 2 here, just to make sure that it works, let's do a send and we'll get a 200. Let me put this back to 1 here. So that's working. So that's one way to do the forbidden check. If your subject is an actual instance of an entity, you actually need to pull that entity from somewhere or create it and then provide it here as a subject. Now, if you don't want all this logic to be happening in your controller, however, what you can instead do is just, in your user service update here, you can pass in the current user, and then you can do this querying inside the update. So for example, let's refactor this to be inside our update method here, which now also takes in the current user. And we're going to say that user to update is this.find1. And then we just got to make sure that we have all of our dependencies in place. So we also want to have the same factory injection that we have in our controller here and put it into our service. And then so at that point, we can also move our ability factory call to be in the service method. Let's put that up here and do current user, definability for current user. And I made a typo here. This is supposed to be in the constructor, not in the create method. So let's do constructor, paste that in there from our ability factory, right? And also import whatever else is missing, forbidden error and the action, right? So then it's gonna do that forbidden check. And then if it's not forbidden, this is where you actually do update call DB, right? Update it in your actual database and then return whatever the value of that is. Right now, we're gonna keep it in just returning a dummy string, right? So going back to our controller, starts to get a little bit cleaner of just having the update call in there, and then the update is gonna have all that business logic of checking whether or not that user can access the user that's being updated, right? So I think if we call our patch here again, it's gonna get us our 403. So that's working the same as before, right? So that's just an alternative way, and I'm not proposing a specific how you should do this. It's really up to you, but generally in NestJS, you want to move all of your business logic inside the services, and then anything relating to routes and HTTP exceptions and stuff like that. That's the stuff that you want to have on the controller, right? So you could do the same cleanup for the create as well, but I'm gonna leave that as an exercise for you. All right, now let's get into the more advanced stuff. So it's probably pretty painful, as you can imagine, having to constantly pull in the user and define the ability and do a forbidden check, forbidden error, and do a can user do action subject, right? It'd be kind of painful to redefine that everywhere. So that's where we can start defining a specific guard that's gonna do the check for us automatically. So let's start working on that. So you might know from my previous video on NestJS authorization is that you can define basically custom decorators if you want to. So the way to do that is first we're gonna create a abilities decorator.ts, and what we're gonna do in here is we're gonna define a new check abilities decorator, which is gonna require a set of requirements, and that's gonna provide us some metadata. We're gonna do set metadata from NestJS common, and we need to provide a key in here, which I'm actually just gonna define in a variable. So we'll do checkability, and then we just pass in the requirements from the arguments, and this actually should be expert const. And it would also be nice to actually define the shape of this requirement. So we're gonna do basically an interface of just action and subject. So make sure to import action and subjects from the factory. So we'll say that requirements is a type of required rule. That's an array, because you can have one to many. So what that's going to allow us to do is we can start providing metadata to a specific route. So I can do something like let's go to a different one. Let's go to our delete. I can do something like at check abilities, and let's import that from our new decorator, and we can provide the metadata in here. So I'm going to say that for this route, to define action, that it is an action.delete on the subject user, right? So that provides metadata, which we can then use in our guards to do the actual check, right? So this doesn't protect the route, but it provides just information. So how do we take advantage of that information? Ideally, we have some kind of guard here, right? That does something like, imagine we had a use guard, abilities guard. Let's go ahead and define this abilities guard that is able to take this metadata and determine if a user can or cannot proceed. So back in our ability folder, I'm going to create another file in here called abilities.guard.ts. Now, to save you some time so you don't have to watch me typing this out, I'm just going to add the code and then I'm going to talk about it. So our guard is going to look something like this. And again, if you watched my original NestJS authorization video, it talks into the details of how to create custom guards. And this is one of them, right? A custom guard is basically a class that implements can activate, and can activate has to return a Boolean. And if the Boolean is true, it says, yep, you can proceed with this route. And if it's false, the default behavior is that it's gonna prevent the request to go through, and it's gonna return a response of 403. Now in our code, what we're doing is we're using the reflector to pull back the rules that we're providing. So as an example, right, in our checkabilities here in the delete route, we're providing this object. So we're just extracting that metadata into our guard, into a set of rules here. And then within this method, we're also getting the current user. Again, I have to reiterate that if you had an authentication solution, typically that user object, if you're using sessions or something like that, is going to be inside request.user. And the way you typically would get that is by getting it out of the context and then getting the request from that context, and the user will be in there. But because we don't have auth in this demo, to keep it short, we're just simulating it with this current user object that actually I didn't define. We'll do that in a second. But imagine that is our current user as if we had authentication. And then the rest of the logic in here is the stuff you've seen before. So we're going to define the ability from our factory, and we're going to go through every single rule, right? Because you can have one-to-many rules. And we're going to say if any of those rules is, it shows that you're not allowed, we're going to throw the forbidden error. And if that forbidden error is thrown, we're going to catch it, and we're going to throw a specific forbidden exception error. And this is just so we can utilize that message. If you just return false, that works true, but you can't use the special message that you have. So I'll show an example of that in a bit. Otherwise, if you go through all the rules and it shows that, yep, you have all of the access, then we're just going to return true, and it's going to proceed, right? So let's see this in action. First of all, we need to define our current user, which we said is in this file, user/current user. So we'll just make a new file in here called currentuser.ts, and we'll just again define a dummy user in here of type user, right? So ID1 is not an admin and is an org ID of 1. All right, and then back in our controller here, we're gonna make sure that we import use guards and ability guard. And now this protects our route with just a set of decorators saying you have to have the access to delete a user. So remember that right now we said that our current user is not an admin, so they shouldn't have access to delete anybody. So let's do a quick test. Back in our Thunder client, we're gonna do a simulation of delete on user/1, and then hit send, and it's gonna say cannot delete on user. And remember, you can provide custom error messages here if you do that in your factory. So for example, we can provide an explicit cannot delete user because you just can't. All right, so if we hit send here, you get back your message, you just can't. And this is where the explicit catch here is very useful. Like I said, if you could just return false if you want to. So if we didn't use this, for example, we can instead do return rules.every rule, and you can just check against the ability directory directly. You can do ability.can rule.action rule.subject, and that's the same thing, right? Because in a guard, you just have to return a boolean. That's all you really have to do. But the disadvantage there is if you hit send here, you'll get a 403, but you can't get that message that you defined. So it is a little bit simpler, but if you are defining messages like we have here, which you don't have to, you can just do an every here instead of try catch. Let me just bring this back to this, right? So let's talk about a couple other tips that I would provide. So even this is a little bit more cleaner than having to do this explicit ability building yourself, right? But it might also be nice to create like predefined rules that you can provide here. So perhaps create a specific required role that you kind of just pass around. Like, so for example, if I'm going to put it in this file, but you can really put these things anywhere you want. So for example, if I define a specific read user ability, which is implementing this interface, right? Or you could also do an object if you want, if you don't want to deal with classes. If we just define the properties of that to be the action and the subject that we want, now we have reusable metadata that we can just pass around. So for example, in our our finds, right? So because this is both for reading users, instead of us having to do this, paste this in here both times, and both of these would have to be read, right? So if you wanted to clean this up a little bit so you don't have to keep repeating this object, you can just use our new read user ability, right? And you can just provide that in here instead, like new read user ability, and we'll copy that down here. And let's do a quick check of just reading. You can do get on /users, and as well as get on /users/id. And just so you know that that actually is working, let's flip the can read user here for non-admins to cannot. And let's do another test on get /users, and we'll get our 403 forbidden, right? Let me bring this back just so you know it's working. So that's another pattern to do it. Now the other thing we can clean up here is, it's kind of painful to keep doing use guards, ability guards. You should know that you can actually define guards globally if you want to. So maybe let's go to our main module or app module. And what we can do here is we can provide a global guard, provide app guard, and we need to import this from NestJS core. And we're going to do use class abilities guard, right? So importing that from our abilities guard file. And now this says that this enables our guard to be global across our entire application. So that means we can get rid of all of these. And we should be able to, let's try a delete here since we have a non-admin. So I expect this to 403, right? So that still works as it did before, right? And then of course, remember that your how you define your permissions here in our factory is really it can be as simple or as complex as you want it to be. So for example, the example we had with the update earlier where it takes in a condition, right? You can't really do the condition at the guard level unless you somehow pull in the data in the guard, which you can do, but that's kind of a mess. So I would recommend as much as possible, do it at the guard level, and if you can't, do it inside the service. And then there is one other thing. I didn't really cover it in this video, but I did in my CASL fundamentals video. Another thing you can do with CASL is, in addition to conditions, you can actually define specific fields that they can manage. So like, for example, one of the things that you can actually add in here is an array of fields, as you can see here. So if you want to restrict it even further than just the entity, but you want to say within this entity what fields you have access to. So for example, maybe you only want to allow a user to be able to read the name of the other users, but maybe your user entity has passwords in it, so you don't want to expose that. So that's how you can also add fields to your specific definitions here. But we didn't cover that, but you can extend your check abilities here to also take in fields. So you want to do, right? So you can provide an array in here as well for your can checks. So that's just, I'll leave that as an exercise for you, but I'm just calling it out that we just defined a simple case here. If you have more complex scenarios, you're going to want to update your guard, right? So like if you were to pass in fields in here, you can pass that ultimately into your rules and can activate in the guard and then run that through, right? So I think this is probably a good place to stop. I've shown you a couple different patterns here. I don't really have a strict recommendation, so it's really up to you to take which of the patterns that I showed you is best for your use case. Whether you like using the guards or whether you like using the check inside the services, or a mixture of both, as I sort of recommended here. And it's also up to you, what the signature of these decorators are if you want to make it more custom. For example, in the NestJS documentation, actually, where they show the CASL integration, their implementation or suggestion is a little bit different, where instead of you passing in an object like this, they actually show an example where you pass in a function like a callback that provides ability, so that your signature looks like this, ability, right? So that's another way to do it. You can provide your actions in here. You would just need to change the signature a little bit, and that is exactly how it's documented in the NestJS documentation. But I find the one I showed in this video a little bit simpler. But I wanted to show that you also use this pattern. The only difference is it exposes the canned ability object to the controller, whereas mine hides it. So it's up to you what your ideal is, right? So again, it's fairly customizable. It really is up to you how you want your API to look. All right, guys, that about wraps up this video. Hopefully you got some good ideas out of that. I definitely personally recommend CASL myself. I think it's a great authorization library, and I've tried a couple other ones before in the past as well, and this is probably at the moment my favorite. Again, if you want to learn more about CASL authentication authorization, I do have those other videos. I'll leave links in the description if you want those. Anyways, guys, I gotta run, so make sure you subscribe if you want to see more of these, and I'll see you on the next one.